Hello class, today we're going to proceed with the method to solve the non-homogeneous second order differential equation. Okay, let's say we have a non-homogeneous second order differential equation which is given by ay double prime plus by prime plus cy is equivalent to function x. In this case, the general solution to this homogeneous equation will comprise of the complementary function. So this complementary function actually is obtained through the associated homogeneous equation of this differential equation. In this case, we obtain this the roots to this differential equation by making this is equivalent to 0. So we call this the first part of the solution as a YC. The second solution will comprise of the particular solution. In this case, it contains no unknown constant, and we represent it with yp. Therefore, the solution for this y is equivalent to yc plus yp. So altogether, there are two methods to solve this second order differential equation. The first method is by using the undetermined coefficient, and the method is the variation of parameter. So today we're going to concentrate on the method 1, which is undetermined coefficient. So in this method, what we do is we make assumption to a particular solution based on the type of the function fx. Altogether, there are 4 categories. So if you have an exponent for function fx, so in that case, your assumption, in this case, the yp is equivalent to constant c times the exponent and x. If it is in the form of a polynomial, which also include a constant in this case, so you will see that the yp will comprise of the cx to the power n plus dx to the power n minus 1, so on. And third category basically is on the trigonometry. So if function fx is in the form of trigonometry, for example, you have a constant sine x or constant sine and x. So in that case, you're going to have the yp is equivalent to c cosine and x plus d sine and x. And the fourth category basically is the combination of the first 3 cases that we have. Okay, so in this example, you need to find the solution for this differential equation. So the first thing is, in this case, we need to rearrange so that we could see that the differential equation actually is a non-homogeneous type, whereby it is equivalent to function minus 2 exponent 2x. Okay. So the first step is we need to find the complementary solution. So complementary solution is obtained by finding the solution for its homogeneous equation. Okay, so in this case, we're going to have our y double prime minus y prime is equivalent to 0. Okay, so we substitute the exponential with m minus squared minus m is equivalent to 0. So in this case, we have the roots m1 is equivalent to 0 and m2 is equivalent to 1. So we have the complementary solution is equivalent to a exponent 0x plus with b exponent x. So we could rewrite this so that it will be in the form, because exponent 0 is equivalent to 1. So we have the YC is equivalent to A plus B exponent X. The next step is we need to find a particular solution. So if you refer back to this equation, we could see that the fx is the exponent type. Okay. So because of that, the particular solution for this is given by the constant c times with the exponent 2x. Okay, so the 2x actually is from this. Okay. And because this is the solution, so our differential equation comprised of the y double prime and y prime. So because of that, we need to obtain the y prime. So from here, so you will get 2c exponent 2x, and the y double prime is you differentiate this y prime, so you will get 2 times with 2c exponent 2x, which is going to give me 4c exponent 2x. So we substitute this y double prime and y prime and similarly y into this original differential equation so that we can make the comparison in terms of the coefficient. Okay, so you will see that this 4c exponent 2x, which is our y double prime, minus with 2c exponent 2x, which is our yp prime, is equivalent to minus 2 exponent 2x. Okay, by comparing the coefficient of this exponent to x, you will see that 2c is equivalent to minus 2, which is going to give us c is equivalent to minus 1. So now we can get the particular solution. So in this case, the particular solution is equivalent to minus 1 exponent 2x. Hence, we can get the general solution for this differential equation, which is comprised of the yc and yp, which is equals to a plus b exponent x minus 1 exponent 2x. We could always double check the solution that we obtain. So in the example 1, we see that the general solution for the differential equation is equivalent to a plus b exponent x minus 1 exponent 2x. So we differentiate this general solution that we obtain, so we will get is equivalent to b exponent x minus 2 exponent 2x. And we can take a differentiation of this differentiation. So we going to get the double differentiation of y, which is equivalent to b exponent x minus 4 exponent 2x. And because of our differential equation, our original differential equation is given by this y double prime minus y prime is equivalent to minus 2 exponent 2x. So what we need to do is we need to substitute the differentiation that we have done of our general solution. Okay, so we have this y double prime, which is this part, is y double prime. Okay, and minus with the y prime, which is equivalent to this. So we will see that is equivalent to minus 2 exponent 2x, which is equal to the original differential equation. So it means that our general solution is the correct answer. Okay, thank you for your attention. So this is the end of this video.